Hello, I welcome you all to this another interesting screencast. The problem reads two boats leave the pier P at the same time and travel in the direction shown. If VA is equal to 40 feet per second and VA is equal to VB is equal to 30 feet per second, determine the velocity of boat A relative to boat B. How long after leaving the pier will the boats be 1500 feet apart? This problem is coming from the Engineering Mechanics and Dynamics, 14th edition by R.C. Benam. Let's start with getting the components of these two boards. Let's start with VA. So VA will have this component like so, and another one like so, and then another one like so, and another one like so. Right, so there we go. This one is this is VA. So VA is VA sine 30. Okay, and then this one is VA cos 30, and this one is VB cos 45, and this one is VB cos 45. Right, so we know that VA is equal to VA sine 30 excuse me, sine 30 I plus VA cos 30 J, and then we have VB, which is VB cos 45 I, and VB sine 45 J. Our VA is equal to 40, and our VB is equal to 30. Okay. So we have been asked to find the relative velocity of A with respect to B, meaning B is our frame of reference. So this is just VA minus VB, which is just equal to, we can grab these, plug them there. Okay, there we go. This minus B. Okay. Right, we bring it there down like so. Okay, there we go. So therefore our VA with respect to B just going to be equal to, then grab your calculator. So we know what VA is. VA is 40 sine 30 and minus 30 cos 45. So this we get a minus 1.2132 I. Let me check it again. So the first one is a 20, then minus 30 cos 45, 1.2132. Then we have the second one, we have 40 cos 30 minus 30 sine 45. So this we get a plus, 13.4278 J. Okay, 40 cos 30 minus 30 sine 45. Alright, so let's find the magnitude quickly. VA with respect to this, VA with respect to B, what do we have? Magnitude. So there we go. These are vectors. With respect to b, okay, square root of minus 1.2132 squared plus 13.4278. Okay, VA with respect to B is just going to be equal to, that's 1.2132 squared plus 13.4278 squared. Okay, square root of that. So the magnitude becomes a 13.48 meters per second. So this is also not meters per second, this is feet per second, right? This is feet per second. This is feet per second. That's fine. Let's draw how this one looks. We have negative x and positive y, so it will be something like so. Something like so, right? And then we have the magnitude, which is closer to y, because y is bigger. So this is v stroke b, this is v stroke b y, and this is v a stroke b x. And then we do have the angle. The angle is there, quite big. All right, so the angle itself, theta, is just going to be equal to tan inverse, okay, tan inverse of 13.4278 divided by minus 1.2132. So theta is just going to be equal to, that's 13.4278 divided by negative 1.2132. Tan inverse of that, we have a minus 84.84 degrees. The reason is minus is because this is clockwise, okay? So 13.4278 divided by a negative 1.2132. Tan inverse of that, 84.83. Okay, so therefore our theta just means is 84.84. We have the angle like this. This is just what it means. Okay, great, which we can see here also. Okay, this is clockwise, like so, clockwise. Okay, great. So we have this. Once we find this, we need now to find how long it takes to move from let me just create a boundary. Okay, to move from, I mean, how long after leaving the pier will the boats be 1500 feet apart? So again, when you look at this, B, okay, B, I mean, B is our reference, okay, and A is we're trying to find the velocity of A relative to B, B being our reference. So we can indicate here something like this and say, we are saying this point here is B, okay, and then this point somewhere there, this is going to be our A, okay. So basically that's what we are saying. Let me move this a bit down like this. Alright, so let me redraw this. I use a straight rule, so we have something like this. Alright, there we go, there we go, there we go. Okay, so we have B, and then there we have A, right? This is our reference. So yes, this is our reference, and then we have A there, right? Okay, so with respect to B, seem to be moving in this direction, right? You have a positive y and a negative x. So then we are going to say, and these velocities are constant, we are going to say our SAB therefore is just equal to VAB times time, and time is just equal to SAB respect to B. Then they are like so, where SAB is equal to 1500 feet and VAB is equal to 13.48 feet per second. So therefore the time is just going to be equal to, so 1500 divided by 13.48, this gives us 111.2 seconds. Okay, 1500 divided by 13.48, 111.28. So this is the time it takes for the two boats to be apart 1500 feet. So we have the magnitude over the relative velocity there. Okay, we have this angle also. There we go. We also have the vector expression for this relative velocity. Okay, there we go. I think this is about it, and I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.